A common scenario in a continuous integration and delivery pipeline is build avoidance. When a source change has been submitted, you don't want to rebuild more of your system than you have to. In a small centralized scenario where everything happens in a single CI server, this can be fairly straightforward. In large decentralized and distributed scenarios, it can be rather tricky, however. In this screencast, we'll take a look at one way of doing it, and how Eiffel can help out with that. First off, let's define the scenario. Tom is one of a few hundred developers of a large system which lives in a common shared repository. Or it could be multiple sources in multiple repositories. It doesn't really matter. What matters is that whenever Tom makes a change to the source code, the system is rebuilt. The system consists of a number of binary components, each of which is built and tested by some machine somewhere in the world. Let's call them Jack, Jill, Jane, and Joe. And depending on what actually changed in the source code, each of these components may or may not need to be rebuilt and retested. Of course, we want to avoid that rebuilding and retesting if we can. So far, so good. But where this gets problematic is when we integrate those components into a coherent system. This is Gary's job. For every source change, Gary wants to assemble a system version containing the new versions of any rebuilt components and the old version of any component that wasn't rebuilt. There are essentially two approaches to this problem. One approach is to implement a mastermind orchestrator who looks at the change, then instructs Jack, Jill, Jane, and Joe to build and test, waits for them to finish, and then instructs Gary to integrate the correct version of each component. The other approach is the choreography approach, where we trust each agent to play its part and interact with its collaborators. There are pros and cons to either approach. I would put it to you that the orchestration approach is superficially simpler, but quickly grows unwieldy in large distributed, decentralized, and heterogeneous contexts, such as multiple more or less loosely coupled groups collaborating on a larger system. This is particularly the case where we are not talking about a single linear pipeline, but rather a software product line situation or an ecosystem, where each component may be integrated in any number of consuming systems. Then the mastermind orchestrator is not only faced with a very hairy scheduling problem, but becomes a single point of failure and a bottleneck. In the choreography scenario, on the other hand, Jack, Jill, Jane, and Joe only know about their own respective component. So when a source change has been made, Jack looks at it to decide whether he ought to rebuild his component due to this change, and Jill, Jane, and Joe do the same for their components. This is simple enough, but what about Gary? How does he know when to create a new version of the system and which components to include? The philosophy of Eiffel is that whenever something noteworthy happens, this is documented through a broadcast event. So Jack, Jill, Jane, and Joe need to communicate what they do, if they do anything. If they all decide to build a new artifact, they will all send events to that effect, Eiffel artifact created events. And because these events reference the original composition, this gives Gary all the information he needs to pick them up and integrate them. All Gary needs to know in advance is that 4 components exist, so when all 4 have reported in, he's good to go. But what happens if Jane decides she doesn't need to rebuild? What if her latest artifact is still valid? How is Gary to know whether she hasn't called in because she's not finished yet, or because she isn't going to do anything? As a form of sibling to Eiffel artifact created event, the protocol provides Eiffel artifact reused event. This gives Jane the means of communicating that she's made a decision and there won't be any new artifact. Instead, she uses this event to point at a previous Eiffel artifact created event, telling anyone who's interested, such as Gary, that it is still valid. Now Gary's life suddenly becomes a lot easier again. All he needs to do is, for every composition of sources created by Tom and his buddies, wait until he has received either an Eiffel artifact created event or an Eiffel artifact reused event for each component. This way, a decentralized pipeline can be created with build avoidance capabilities without any central orchestrator, with cleanly separated concerns and without communication backdoors between the agents in the pipeline.